Assalamualaikum and hi everyone. My name is Nurul Adawiyah Mazani and I'm from Group SP8 and today I'll be presenting the Pressuremeter Test. The Pressuremeter Test. The Pressuremeter Test is a type of in situ test, which means it's performed directly in the ground rather than in lab. The main purpose of this test is to find out how strong and stiff the ground is, and more importantly, how it behaves under pressure, just like it would when supporting a building or structure. This test provides control and well-defined stress and strain condition, which allows engineers to understand both the strengths and deformation properties of the soil. In simple terms, it helps answer the big question for engineers, which is how much load can the soil safety carry and how much will it deform to settle under the load. The results for PMT are extremely useful in designing foundation, tunnels, and retaining structures, and in assessing for soil failure potential, especially for soils that may behave plastically and fail under hard loads. Here is equipment. The main equipment used in a pressuremeter test is a pressuremeter probe. This probe is a cylindrical device fitted with inflatable membranes that can expand outward when air or water pressure is applied. The other essential parts include a pressure control unit, which is to regulate and measure the applied pressure, and a data recording system to measure how much the soil expands or contracts. These tools work together to capture how the soil reacts and it is gradually pressures. And the procedure of this test is conducted in several steps, which is number one is probe insertion. The cylindrical probe is inserted into a pre-drilled borehole at the desired testing depth. The second one is inflation. The probe is slowly inflated using air or water, which causes it to expand and push against the surrounding soils. And step number three is data collection. As the pressure increases, the amount of soil deformation is recorded. This data helps create a pressure volume curve showing how the soil reacts to increasing pressure. And lastly is deflation. Once the maximum pressure is reached, the probe is deflated and the soil's elastic rebound is observed. These steps show how much of the soil's deformation is recovered versus permanent. Through these steps, engineers can clearly see how the ground responds to loading, from initial compression to potential heading or failure. Now we move on to the equation and parameters. The key parameter obtained from this test is the pressuremeter modulus EP, which represents the stiffness of the soil. It's calculated using the relationship between pressure change and volume change from the test data. The equations are as stated here. And EP is in pressuremeter modulus in kilometer pascal, and the next one is Poisson ratio, and V naught is the volume of the uninflated probe at the ground surface, and delta P is the corrected pressure increase in the center part of the straight line portion of the pressure volume curve, and delta V is corrected volume increase in the center part of the straight line portion of the pressure volume curve, corresponding to the delta P pressure increase. And Vm is the corrected volume reading in the center portion of the Vm volume increase. This modulus helps engineers predict how much foundation is set under the different loads. The results can also be correlated with the standard penetration test SPT and SST to provide a more complete understanding of soil behavior. Now, let's connect this to what we discussed earlier. How PMT helps engineers understand how the ground will behave under pressure. When the probe expands, it applies pressure to the surrounding soil, mimicking how a ring structure will press down on the ground. By observing the soil's reaction, whether it's stiff, compresses, gradual, or yields, engineers can determine elastic behavior when the soil returns to its shape after unloading, and plastic behavior when the soil starts to deform permanently, and lastly, failure point when the soil can no longer resist further pressure. This understanding helps engineers design safer, more reliable foundations and avoids excessive sediments and failure. Let's look at some advantage and disadvantage of this pressuremeter test. Okay, the advantage is this pressuremeter test can be used in almost all soil types, which is can provide direct and reliable measurements of soil stiffness and strength. It's relatively faster and cost-effective compared to many lab tests. It is very useful for large-scale engineering projects. And the disadvantage of pressuremeter test is it is not suitable for very soft and loose soils. It requires skilled operators to ensure accurate readings, and the equipment can be easily damaged. It also has a limited depth penetration depending on site conditions. To conclude the pressuremeter test, it is a key tool in geotechnical investigation. It provides direct in-situ measurements of how the ground behaves under loading. It giving engineers essential data to design strong and safe foundation, predict settlement behavior, and classify the site's geotechnical conditions. Because it measures soil deformation and strength in its natural state. It eliminates the need for costly lab tests and leads to more accurate real-world results. In short, the PMT helps us understand how the ground really behaves under pressure, making it a cornerstone of modern foundation design. That's all for me. Thank you.